We're going to talk today about reducing fractions, and the cancellation that we're going to talk about could be in the multiplication of two fractions or in the simplification of a single fraction, but the principle will be the same either way. One of the things to note is that simplification is just to try to make the fewest terms in your expression but maintain the value. Notice that whenever you see in your notes something that says question, what that means is that on a vocabulary quiz where you don't get to use your notes, this will be a question that I'll ask you. You don't have to give my exact answers, but I try to give you something that will hold the idea with giving you a minimum of wordiness to try to deal with and make it easy for you to produce for yourself. So what does it mean to simplify an expression? Fewest terms equal value. And just a reminder, here's a simple arithmetic statement, 3 times 2. And to note, that has a value already, and most of you look at that and know what the value is. But when I change this to its equivalent 6, that's technically a simplification. I've turned a 2-term expression into a 1-term expression, but I haven't lost its value. How do you multiply fractions? Well, sometimes in elementary school, you might say top times top makes the top, bottom times bottom makes the bottom. But the easiest way to say it is just straight across. Just A times C makes AC, B times D makes BD. So as an example, if I had 3/5 times 2/7, I just multiply straight across. 3 times 2 is 6. And then 5 times 7 is a 35. Sorry, my pen's acting just a little wonky. So we're going to reduce fractions. And here's a question. Again, notice that this is a thing that will show up on a vocabulary test. How do you simplify fractions? And we're talking about either multiplication or reducing a single fraction. And the answer is factor cancel. The idea of changing a fraction is that we're going to discover a hidden 1 multiplier. So you can pause and read these 3 statements here, and then play again to watch the examples. So, the division question works well for numerical fractions, but it fails whenever you do algebraic fractions. So it's good to know the key principle, and the key principle is to discover that hidden 1 multiplier. So this is not the way that you typically would do this, and I'm going to show it to you this way one time, just so it really shows the principle of what's going on. So I'm going to call this top times top, bottom times bottom, and I'm going to combine a couple of steps. I'm going to say that's a 3 times, and I'm going to use the multiplication dot. But instead of calling that a 4, I'm going to call it a 2 times a 2. And then across the bottom, instead of calling that an 8, I'm going to call it a 2 times a 2 times a 2. That's the 8. 2 times 2 for 4 times 2 again for 8. And then times that by 5. And then I'm going to do a little rearrangement. I'm going to put the 2 2's first and then the 3. So I'm just doing the commutative property that allows me to rearrange things. And then I'm going to call this 2 times a 2 times a 2 times a 3. And then I'm going to make one more change. I'm going to call this a 2 times a 2 times a 3 over a 2 times a 2 times a 2 times a 3. But instead of writing it in a single fraction, I'm going to write it as 2 separate fractions. Whoops, that's not supposed to be a 3, sorry. Let me go back and, whoops, there's my mistake there and there. So that was a 5 that I miscopied there. So what I see here is a number divided by itself. That's a 1 multiplier. That's 1 times 3 over 2 times 5. So instead of calling it 1 times 3 over 2 times 5, let's call that 2 times 5 a 10. And why do we need to write a 1 times? Because multiplying by 1 won't change things. So let's just call that 3/10. Now let's look at another way of doing that same problem. We could have done it this way. We could have said, I see that the 8 has a 4 built into it. So I'm going to call that 3 times 2 times 4. times, and instead of writing it as two separate fractions, let's go ahead and combine them into a single fraction, a 4 over a 5. And then what I see here is that I could do that same rearrangement that you saw up above, and I could put that 4 first in both the numerator and denominator, and I could see a 4 over 4, which, by the way, that's what this is right here. And 4 divided by 4 is 1, and the 1 multiplier can be ignored. So quite often what I do is I just mark those out and say, oh, it's 3 over 10. Now here's the most common way that you see it done in elementary junior high. You ask this question, what goes into the top and the bottom? And I see that a 4 can go into the 4 on top and the 8 on bottom. So I say 4 goes into 4 once, 4 goes into 8 twice, and then top times top, bottom times bottom. 3 times 1 is 3. 2 times 5 is 10. In terms of the thing that's most efficient, this last example here is the one that's most efficient. But we have to be aware of that principle of the hidden one multiplier so that when we get to algebraic fractions, we have an idea of what's going on. Now, what I recognize is that the 4 goes into the 32 8 times. And I'm still going to rewrite this, but when you begin to see that you can imagine those in your head and do the work in your head, then just skip right to it. So what I see is also that the 9 and the 18 are related to each other. 9 times 2 is 18. So this time what I'm going to do is factoring, but I'm going to use the greatest common factor as opposed to a complete factorization. So in that first example, I broke the 8 all the way down to its primes. But this time, I'm just going to call the 4x a 4x. But I am going to state the multiplication. That's a 4 times an x. And then I'm still going to put it all into one fraction right now. But instead of calling that an 18, 3 times a 3 times a 2, I'm going to call it a 9 times a 2. So a 9 times a 2 makes the 18. Y to the third, by definition, the exponent tells you how many factors of the base you have. I have 3 factors of y. So I'm going to go ahead and write that as a y times a y times a y. Then on the bottom, I'm going to leave the 9 as a 9. I'm going to use the definition of the exponent and call the y squared a y times a y. But remember that I said that I see that 4 is part of the making of a 32, 4 times 8. So I'm going to re-express the 32 as a 4 times an 8. And then the x, x squared rather, I'm going to call an x times an x. Now, at this point, I think I'll do this the last time of all for this particular problem. Now, I'm going to rewrite this fraction this time, but I'm going to quit doing it after this problem. I'm going to call the numerator, first of all, a 4 times a 9 times a 2. And then I'm going to put the variables alphabetically, an x, and 3 factors of y. Y times y times y. So I've taken these 1, 2, 3, 4, 5, 6, 7 factors and just rearranged them. On the bottom, I'm going to do the same thing. I'm going to put the 4 first, the 9 second, so there's the 4, there's the 9, and then the 8 after that, so I'm just putting them in numerical order. And then I see 2 factors of x, so I'll put those alphabetically, an x times an x, and then 2 factors of y, so a y times a y. But instead of putting one long fraction bar, I'm going to put lots of little tiny fraction bars here. And the only reason I'm doing that is to emphasize that what we have here is 4 divided by 4, 1, times 9 divided by 9, 1. I could, if I wanted to, go ahead and reduce this 2 over 8 into a 1 over 4. I don't need to explain that. That's about a 5th grade concept. And then this x divided by x, even though I'm unsure what x is, I know that it's a number, and it's the same number top and bottom. Therefore, it goes into itself one time. And then the y over the x can't be reduced. It's not a 1 multiplier. But the y over y here is a 1 multiplier. And the y over y here is also a 1 multiplier. So let's see. If I ignore those 1 multipliers, I'm going to multiply the two remaining fractions, top times top, bottom times bottom, 1 times y, y, 4 times x, 4x. Now, when you begin to see all that's going on here, you'd go back here at the original thing and you'd say, well, that 4 is going to cancel the 4 factor that's inside the 32. And since 4 times 8 is a 32, it'll leave an 8. And this 9 is part of the 18. 9 times 2 is 18. The 9s will cancel. But 9 times 2 is 18. It'll leave the 2 behind. And at this point, I'll see the 2 over the 8 right here. And I know that'll reduce to a 1/4. But what about this? There's 3 factors of y here. And there's 2 factors of y here. Well, I know that 2 factors of y will cancel 2 factors of y and leave a single factor of y. But by the same token, what I see over here is a single factor of x here, but 2 factors of x there. And that single factor of x will cancel one of the 2 factors, but it won't cancel them both. So I know that this x will cancel one of the factors but leave an x. Now let's see what's left. Well, we have the 2 over the 8 that'll reduce to a 1 over 4, but I have that 1 multiplying a y, which is simply y. And then I have this 8 multiplying this x right here, 4x. So that's the way you do it with simplicity. And that's what I'm going to do for the rest of the examples here. So I see that x squared is an x times an x. And this x is going to be able to cancel one of these 2, but it's still going to leave an x in its place. So what I do is I just say that in my mind and say, well, that x will cancel one of the 2 x's, but it'll leave an x factor right there. And this y will cancel this y. A y divided by a y is a 1. Now, when you mark everything out, remember that that's understood as a 1 multiplier. So top times top is actually 1 times 1. And then on the bottom, I have this 8, and don't forget, we still have that x, so 8x. That's the way it's simply done. Now, whenever you see a fraction or a decimal or a percent, and then it says the word of, that of always means times. Simple example, everyone knows that half of 8 is 4. Well, does that mean 1/2 plus 8, 1/2 minus 8, 1/2 times 8, or 1/2 divide by 8? Of all those 4 operations, which one gives the answer you know is true? And it's the 1/2 times 8. Just to note, 8 over 1, and then I could cancel the 2, and 2 times 4 makes 8. The 2 cancels, it leaves the 4. There's your 4. So with that in mind, just remember that that's an understood time sign there. So now I'm going to ask, does anything go into top and bottom? So I recognize that 9 is 3 times 3, and 15 is 3 times 5. So I could cancel those 3's, and 3 times 3, one of the 3's cancels on the 9. 3 times 5, the 3 cancels and leaves the 5. But by the same token over here, 8 times 2 is 16. So 8 over 8 makes the 1 multiplier. So I mark the 8 out. But then 2 times 8 is 16. So I cancel the 8. I left the 2. Now how do you multiply fractions? Straight across. Remember, up on top, that's technically 5 times 1. And then down on the bottom, 2 times 3. And we're done. Now, there are some things that you can do that you may remember from your elementary junior high days. Again, remember that of is a time sign. And you're going to see a lot of problems this year that are just this simple, 7/8 of 24, or 7/8 times 24. So here is the junior high model of 7/8. Actually, probably more like about a 4th grade model. 8 means to break whatever your object is into 8 equal parts. So break into 2, break into 4, break into 8. And then the 7 on top means that I get 7 of the 8 parts. So 7/8 of something means break it into 8 parts, take 7. So at this point, let's just stop and say, what if this is a cheesecake? And your cheesecake is going to cost $24, but it's got 8 slices in it. How much is each slice worth? Each slice is worth $3. 8 times 3 is 24. So if each of these slices is worth $3 and I get 7 of the slices, then I get 7 times 3 is 21. Now, if we did it in the method that we're talking about, we always put a whole number over 1, and then we ask, can I cancel anything? Oh, I know that 8 times 3 is 24. So 8 cancels the 8, but it leaves the 3. And then I have 7 times 3 on top, 21. 1 times 1 on bottom, but 1 denominators don't need to be written. Please notice that 1 numerators must be written, but 1 denominators don't need to be written. So that's more the way we do it. But remember, that can show up also in variable form. So the thing to remember is that that x squared is actually an x times an x. You don't have to write it, but you do have to recognize it. And that x times the x will allow a cancellation of that one factor of x. Now, is there anything else that can cancel? Well, 3 and 4 don't share a common factor, so all I'm left with is x times 3 on top. So we call that 3x. It's not wrong to say x times 3, but the common expression would be 3 times x, or 3x. And then on the bottom, I have 1 times 4, so a 4. So canceling fractions is supposed to be quick and easy. So now it's your turn to practice.